And is it, you know, I'm going to teach from the board today, and so I am going to, Gus, please be quiet. I'm going to teach from the board today because it's the way I want to do this thing, but that means that I can't just record and post up there from the screen. Instead, Kiki's going to be taking a video of me. So it is going to be recorded, it's going to be going up, but it won't be as many of your backs and heads or anything. Okay, let me just think, get my head wrapped around here. Okay, so we've been working on trigonometry. What does trigonometry do for us? What's its value in our life? Good. In triangles, if we have certain information, we can find other information. Previously, we worked with angles. If I know that this is 30 and this is 80, can you find the third angle? Because you know all three angles add up to 180. No problem. That's old stuff. We learned that in certain triangles, right triangles, if I know two of the sides, I can find the third side using what? The Pythagorean theorem. But that only works in right triangles. And then we said, okay, but what if we don't even have two sides? What if we have one side in a right triangle and then another acute angle?
Then we do the sin 43 equals.
Then we can use sine, cosine, or tangent to solve using right triangle trig, right? That's where we've been. Right. We took it one more step and said, okay, we could even do this to find the angles. If this were a 3-4 triangle, we could find this angle using inverse trig. Now, this is all limited because all this skill that we've got only applies to right triangles. But there are other triangles besides right triangles. What about them? Before we begin digging into this, I want to make sure that we're clear on how we label these things. I want to label this triangle. I want to be able to discuss it. So that when I'm pointing at it and saying, okay, look at the angle. Which angle am I talking about? So I'm going to label it. A, capital letters, B, and C. Now when I say look at angle A, do you know what I'm talking about? Yes. I also want to refer to the sides. And it gets a little bit tedious talking about side AB, and side BC, and side CA. So there's a convention that says if I take the angle measure that's facing it, the opposite side is the lowercase letter. So if this is angle A, this is lowercase a. If this is angle B, what's this side? Lowercase b. Okay. And if this is angle C, what's this? Lowercase c. Now, I want to figure out how to use trigonometry, sine, cosine, or tangent, in this triangle that's not a right triangle. It's a problem because I don't have any right angles. So I'm going to build myself a right angle. I'm going to go to this angle B, and I'm going to drop an altitude. I now have a right angle, don't I? Because that's what an altitude is. It's perpendicular to the base. So I'll call this h because it's the height. And I don't want to get into where this is because it's not b, it's less than b. This is some part of b and this is the rest of it. I'm just going to kind of ignore that for a second. And I'm going to look at angle A. If I take the sine of angle A, what's that equal to? I know, it's so... Katoa. Not quite. Sine, so katoa. Sine is the ratio of 1 over 1.
H over C.
H over C, good. So katoa. So the sine of an angle is equal to the opposite over the hypotenuse. So if this is the angle I'm talking about, what's the opposite side? H. And what's the hypotenuse? C. So the sine of A is equal to H over C. Thank you, Gus, you did. I thought the H you were referring to was like so. Let's do the same thing for C over here. What's the sine of C?
H over A.
Good. Opposite over hypotenuse, this time that would be H over A. Now, I'm going to solve both of these expressions for H. If I want to solve for H, right now it's being divided by C, so I'll multiply by C. And that gives me that C times the sine of A is equal to H. What do I multiply by over here to get rid of the denominator? Multiply by A. And I get that A times the sine of C is equal to H. Well, both these things are equal to H now, which represents the same thing in the same problem. So I'm going to set those equal to each other. C times the sine of A is equal to A times the sine of C. Okay, it's cleaner, but I'm going to make it really clean. I'm going to divide by AC. Lowercase a is C. On this side, we'll cancel the C. On this side, we'll cancel the A. I'm going to show that.
Sine A equals sine.
And what I'm going to be left with is that the sine of A over A is equal to the sine of C over C.
Is that our equation?
What does that say, though? It is confusing. Sorry?
Didn't you just get rid of A and C?
Well, on this side I divided by AC, and so I cancel the C's, leaving the A. On this side I divided by AC, canceling the A's, leaving the C's. What does this say? Well, first of all, I'm going to write it up here. On the top of your worksheet for today,
The sine
on
of
page
an angle
3,
equals the opposite angle.
it says law of sines. And I want you to write that the sine of A over A is equal to the sine of B over B is equal to the sine of C over C.
This is page 3.
Page 3, top of the page. It's called the law of sines. And it's kind of interesting. If I take a triangle, let's say that I tell you that this side is, I don't know, 5. And I tell you that this angle opposite it is 30 degrees. If you weren't in geometry class, you were just like some person on the street. And I said, now I'm going to make this angle twice as big. It's going to be 60 degrees. And I've told you this dinosaur idea, right? That if an angle is so big, then the stick opposite it has to be big. Remember this? The biggest side matches the biggest angle. So if this is 30 degrees facing a 5-unit length, and this is 6 degrees, what would you expect this side to be if you didn't know geometry? 10. Right? Because if the angle is twice as wide, then it should be twice as big side on the opposite side. We know that's not true, because this is a 30, 60, 90 triangle. So if the smallest side is 5, this is a right angle. How big is the hypotenuse? 10.
And then 5 is 2.
5 root 3. So in other words, when an angle doubles, the opposite side doesn't double. When an angle triples, the opposite side doesn't triple. It's not in a linear relationship that way. Instead, it's in this sinusoidal relationship. As you increase A, the opposite side does increase, but by the sine of A, not by A value itself. Still hard to understand. Let's do a first problem here. Can I borrow this for just a second?
You can even see it.
I do recommend for these problems that you organize everything. Are we blocked? Would you do me a favor and just move over one seat, please? For the video purposes. Okay. I do recommend for this problem that you organize your information. We have an angle A, an angle B, an angle C, side A, side B, side C. For this problem, what information are we given?
Well, I think there's also the angle is 35.
Oh, thank you. Good, thank you. So let's fill in here. Do we have angle A? 71 degrees. Do we have angle B? No. Do we have angle C?
Yeah.
35 degrees. Do we have side A? It's listed, it's important, it's valued as part of this problem. It's an X. We don't know its value. Do we have side B? Opposite angle B, no, nothing there. Do we have side C? We do, it's 12. The law of sines is a proportion. It's the sine of an angle over A equals the sine of an angle over its side. proportions. Remember how we did these before in like similar triangles? If we said like x over 12 equals 5 over 6, you can solve it with cross multiply. But the only way it works is if you've got one ratio that has two values in it, and the other ratio that's got a variable and a value in it. That's the way it works. I can't have like three values, three variables. So, thank you. Do I have a ratio that's going to work? Question? Finn?
Oh, I was going to answer this.
Yeah, go.
Oh, 71, sine 71 over x equals sine 35 is 12.
You're choosing sine of A over A equals sine of C over C, right?
Yeah.
Totally agree, because A has two parts to it, the angle and side. And C has two parts to it, the angle and side. So I'll say the sine of 71, because that's angle A, is to the opposite side, x, as the sine of C is to its opposite side. That's my setup for this. I've applied the law of sines. I'm presenting a proportion that works for this triangle, not a right triangle. Now I just solve it. How do I solve a problem like this? Cross multiply, just like we did in similarity. So when I cross multiply, I'm going to get x times the sine of 35 equals 12 times the sine of 71.
Should we have for the sine first?
I would say no. Good question. If you plug this into a calculator, it might feel better to you because it'd be a number instead of this weird word and number combo, but it would be this long number going on forever. And in order for you to write it there, you'd be truncating it or rounding it. And you've changed the value there. You've reduced the precision. So leave it like this until you get all the way to the end where you say x equals. Then plug it into your calculator at once. So we've got x times sine 35 equals 12 times sine of 71. We want to solve for x. So ask yourself, what's being done to x right now? It's being multiplied.
You have to divide by sine.
Right, it's being multiplied, so the way we undo that is divide. Divide by sine 35, divide by sine 35. On this side, those cancel, they make a version of 1, so now it's just 1x equals 12 times sine 71 over sine 35.
What? And
Now we can use our calculator. We've solved for x completely. You've represented this now in its precise form, which is exactly what I want. Now give me the decimal equivalent. Everybody take your calculator.
Wait, Mr. Allen, what did you do?
What did I what?
What did you do?
I divided both sides by the sine of 35.
Oh.
I cross multiplied,
Oh, you cross multiplied.
and then I divided. Okay. Ooh, before we use our calculator for trigonometry, what should we make sure is true? It's in degrees. Look on the bottom right-hand corner, make sure it says degrees. If you're unsure, do the sine of 30. That should always work for you. What should the sine of 30 come out to?
0.5.
0.5. If the sine of 30 doesn't come out to 0.5, your calculator is misset or you're misusing your calculator. Remember how your phones are opposite? Instead of doing sine, then 30, enter. Your phones, you do 30, sine. So doing sine of 30 helps you remember what kind of calculator you're working with. All right, so let's see. 12 times sine of 71 divided by sine of 35. Okay, I'm going to show you two answers here. You tell me which one is right.
What are we rounding to?
Let's go hundredths. I know the thing says to the nearest 10, but I always prefer hundredths. Did anybody get 9.97? Raise your hand for me. Okay, about 5, 6 of you. Any of you get 19.78? Raise your hand. More of you. Okay. This one is right, this one is wrong. There's a calculator operation that is very, very common that causes this. When you start entering this in, you do 12 times the sine of, and the minute you hit sine, the calculator introduces a parentheses. And when you put 71, it's like, cool, you're going to see sine of 71. But if you then divide by sine of 35 before you close the parentheses, you're taking the sine of this whole thing. So you have to make sure to close that parentheses. If you got this answer, please try it again and make sure that you close this parentheses after 71. Make sure that you can get 19.78.
0.78 or 0.8?
Say again, please.
Do you want us to round it up to 0.8 or 0.78?
This worksheet says to round nearest tenth, so sure, you can round it to 0.8. Five, I can successfully use my calculator to find out this value and get 19.78. 3, I made a mistake initially, I'm now good with it though. 1, I'm struggling, I'm still not getting it. Okay, good, hands down. So this is the first application of law of sines. We can use it to find missing sides in non-right triangles. The second application. Any guesses? Any predictions? First application was finding missing sides. Finding missing angles. So let's go to number 9. Last page. Yep. And again, I strongly urge you to organize your data. In other words, write A equals, B equals, C equals, A equals, B equals, C equals. When you get to pre-calculus, you won't just be solving for X, you'll actually be solving the whole triangle where you're filling in all the missing parts, and this is an important tool to get you there. May as well get the habit now. Okay, what do I know? Do I know angle A?
Yeah.
What is it?
77.
Secret. Do I know B?
No.
X, good. C? No. Do I know little a?
Yeah.
Good. Little b? Little c? No.
So A.
Do I have my ratios?
Yes.
Because I got a matching set of a's here, I'm going to use a. Sine of a over a.
Wait, how do you know 14's A?
Because it's the side that's opposite
Oh,
angle.
right.
Okay, and then I'm going to use sine of b over b. Because those are the two ratios I got. One has a variable, the other is both parts. So I'll fill it in. Sine of 77 over 14 equals sine of x over 9. So far this feels just like the last one, right?
Yeah.
Okay.
More.
What's next?
Cross multiply.
But
Why?
Because it's proportion. Right?
Because it's a proportion. Okay. But the reason we cross multiply in a proportion is to get rid of denominators and stuff. Really, the goal is to solve for x, isn't it? There's two things being done to x right now. What are they?
Multiply by sine and divide by 9.
Not multiplied by sine, because sine's not a
Sine
number.
of x.
Right, it's being
Divide.
signed, and we're dividing by 9. Can we get rid of the dividing by 9 now? Multiply by 9. So instead of doing cross multiplying, I'd say just multiply by 9. Saves you a step. Could you cross multiply and then divide by 14? Yeah. So now we've got 9 times sine of 77 over 14 equals the sine of x. Okay, we're closer. But we still don't have what we want. We want x. Right now we've got the sine of x. How do we undo what's being done to x?
Sine
Wait.
Sine minus.
Good. Sine equals negative 1 exponent called the inverse sine. And if I do it to the one side to get rid of the sine, I have to do it to the other side to keep the equation balanced. When I do it over here, it cancels, leaving just x. And over here, I'm going to get the inverse sine of 9 times sine of 77 over 14. And depending on your calculator, you can either do this all in one fell swoop again, make sure to put parentheses in, or you can work your way from the inside out. If it's your phone, I might do 77 sine.
Wait, why doesn't the sine cancel out on that side?
On this side?
Yeah. Is it,
Because there's other stuff in the way.
okay.
The 9 and the 14.
And you couldn't just cancel it out and leave the 9?
No, it doesn't work that way.
So it's
And you'll remember you access this inverse sign by doing what? The yellow button, the second, and then sign.
So you do 2 parentheses at the end of closing.
You're going to put, it's going to open a parentheses here, so and it's going to open a parentheses here too, right? So you'll want to introduce this parentheses for sure.
Divided by 14.
This one's not as important because it'll do it automatically knowing you're done. We get 38.78 degrees.
38 points, yo. 38.
You have to do cosine and then sine again.
This is not cosine. This is second sine.
So this is sine minus 1 time. That's basically just how you wrote it up.
Just how I wrote it, exactly.
Yeah.
All right, any questions? All right, one more possible scenario that might throw you off with law of sines. It's number 4 in your worksheets. Actually, no, it's number 6. Number 6. Yeah, you'll see that fast.
Yeah, they're fast if you miss it early.
I'm sorry?
They're fast if you miss it early.
Well, I am a little bit better at geometry than you, I accept that, but I think you'll find them easy too.
Yeah.
Okay. How do we get this thing rolling?
Label.
Label, I love it. Let's go ABC.
Does it matter?
It doesn't matter.
Oh.
Unless you're like talking to a friend, you want to make sure that you've labeled them the same way so you can have that communication. All right, and now what? Let's get a little chart, right? Let's make a little chart to organize our data. A equals, B equals, C equals, A equals, B equals, C equals. What have I got? Angle A is 33. Angle C is 58.
And then side C, lowercase c.
Side lowercase c is 25.
And then side lowercase
Lowercase what is that?
D is X.
Lowercase d is x. Ruh-roh, George.
Uh-oh.
What do we notice?
You don't have another one.
So you
We don't have the other match ratio.
move it.
This is great. We like sin of c, right?
But I don't know if you moved it, it still wouldn't work.
But what's the
then
other
make it
ratio?
Y and then plug stuff in.
Yeah.
Put y and plug stuff in?
Yeah.
Okay, what is my y?
B. Big B.
Big B.
Yeah, so you do, wait, you
No,
do
okay.
sine of 58 over.
Hold on. Piper.
You could just solve for the angle by adding
Oh.
33 to 58.
What do we know about the 3 angles in a triangle?
Yeah.
It's 180. So we can find that easily, actually. We can say 180,
Well, can you just do that with all of them?
91, 89.
And
80,
then,
91, so that's going to be 89.
wait, Mr. Erling, can't you just do that for all of the problems and then do the Pythagorean theorem and then just skip all this?
Yes, you could find the missing angle for each of the problems. No, that would not help us because in most of the problems we've already got the paired ratios we need, so finding the third angle wouldn't help. In this one, for example, finding this third angle wouldn't give us anything new. And then your later statement about using Pythagorean theorem, no, because these aren't right triangles. Pythagorean theorem only works in right triangles. Okay, so we're going to do sine of C and this one. Sine of B over B. So the sine of 58 over 25 is equal to the sine of 89 over x.
What does it say?
That says 25.
This is 25. Is that what
You
you're?
might want to rewrite that.
For the video.
Yeah.
I wonder what all those confused looks were for. What's 2J?
I thought you were talking about like Trader Joe's or something.
Yeah.
We don't multiply by x, right? We would just.
We could multiply by x, but if we did that, we'd then have three things going on over here. That's not easier. Let's cross multiply. So x times sine of 58 equals 25 times sine of 89.
No. That's sine 50.
Yeah, because we've got x, it's being multiplied by the sine of 58. We want to get rid of that, so we do the opposite. We divide by sine of 58. If we do it to one side, we have to do it to the other side. These cancel, making a version of 1, so x is equal to 25 times the sine of 89 over the sine of 58. And let's use our calculators to get a decimal approximation of that.
Oh, well, I just did. Yeah, I still did. No, I did. I just
Did anyone get 24.15?
No.
No one did good. That's what happens if you mess up the parentheses. This is what we should get.
It's 229.5.
Yes. Okay, scores. 5. I am the law. 3. I'm willing to follow the law if it's convenient. 1. I'm breaking law. Law of science. Okay, good. Last piece for today is, as Xander was so excited about, the word problem.
Oh yeah, so.
Can I get somebody with a reading voice to read problem number 1 to me? Who was that? Gus, bring it on.
Number 1,
Yep.
Casey cites the top of an 80-foot tall lighthouse at an angle of elevation of 58 degrees. If Casey is 6 feet tall, how far is he standing from the base of the lighthouse?
Oh, we have to take the height to.
Do we have to draw the line?
Okay. Believe it or not, that's a lighthouse. Casey's standing over here.
A bit wide in the base.
Yeah, I'm worried about weather. So Casey checks out the lighthouse. He's like, oh, that's really cool. And he looks up at it. And he's 6 feet tall. And the lighthouse is 84 feet tall. You must have read that on a little plaque as he walked by, right?
Yeah, like
But the question is, how far is he standing from the base of the lighthouse?
But he's 6 feet tall.
He's 6 feet tall.
Right, 6 would be.
But then that's not a triangle.
Excellent point, Finn. This is all about right triangles. So we're taking the word problem, we're trying to turn it into a right triangle. That's not a right triangle, is it? This 6 feet thing breaks it. But do you agree that whatever distance this is the same distance as from his eyeball to the center of the thing?
Yeah.
And is that
Well,
now?
it's not the center.
Now it's 84. not
It's
6.
6.
No,
So it would be
it's
Well, 6 is this distance, right?
Yeah, but 6 isn't half of 84.
It's not half. Oh, I meant center side to side, not top and bottom.
Oh, okay.
How tall is this?
78.
78 feet. So that the combination of this and 6 makes the 84 for the whole lighthouse.
It's still not a triangle.
It's not?
It is now.
Oh, it is. But what about the bottom?
Talk more. What makes you say it's not a triangle?
Oh, wait. I was just not ready.
You're trying to include this part, right?
No.
Is that why you said it's not a triangle? Because it looks like it's like a trapezoid or something?
Never mind.
Okay.
So now the lighthouse is short.
Oh, wait, this is.
Well,
Like, not
we're
actually
using a
short,
shorter
but
part of
it's
it.
bottom one.
Yeah, we're
But
only
it's the
using
same
78.
bottom line.
But the base will still be the same, right?
Can we accept that this is a right angle?
Yeah.
Yeah. Well,
When they measure the height of something, it's always measured as a right angle, right?
Oh,
Draw
what
an
about the
altitude,
58
exactly.
angle?
And then the 58 degrees has to go somewhere. And this is what this set of word problems is all about. What is an angle of elevation and what is an angle of depression? Angle of These words are going to be used in the word problem, and you got to know what they mean because it depends on where you put the angle.
Well, it has to be the angle that's right there, the little one.
This one?
Yeah, because then you can't solve the problem.
Well, you could solve it if it were up here, couldn't you?
Well, that would be depression.
What it is,
You're right that it's not the angle of elevation up there, but it's not the angle of depression either. So Finn's right. This is the angle of elevation, and I'm going to give you a visual to think about the angle of elevation. It always starts from the horizon, looking straight out. And if you elevate your gaze, that's an angle of elevation. Similarly, if you were to look straight out and depress your gaze, that would be the angle of depression. Yeah. So we'll do one of those in just a second. Now, all I care about is the little right triangle, so I'm going to redraw it over here. This is 78, this is 58, and this is x. When I strip away all that junk, does this look like our SOHCAHTOA problems?
yes.
It does. What are our steps? Number one. The eyeball. Good, exactly. So we'll put that here next to the angle. Step two.
Label
Label.
opposites of
This is opposite, adjacent. Step three.
TOA.
Sine, cosine, or tangent, which means SOHCAH or TOA.
TOA.
Good. In this case, we see O and A, so we're going to choose TOA. Step four.
Have the expression without it plugged in.
Good. Put out the expression, the formula, without any details. In other words, the tangent of the angle is equal to the opposite side over the adjacent. Step five is where we customize. Question?
Yeah, how do you know that's the right angle?
One of the assumptions you're going to have to make on most of these problems, when they talk about the height of something, the way you measure the height of like how high my hand is off the ground is not going slanted down to the floor. It's always an altitude. It goes right down perpendicular to face. So we're assuming if they're telling us the height, that it's perpendicular.
Wait,
Wouldn't work for the Leaning Tower of Pisa. Yeah.
how would that be 6 feet tall if we measured it from his eyes?
Agreed. That's a flaw in this problem, isn't it? Like the top of his head would be 6 feet tall, his eyeballs would be 3.5 inches lower or whatever. And if you want to build that into your problems, I mean, it's super precise and have like a, you know, that kind of detail, you can. Otherwise, you can assume that. All right, step five. Once we've established what the formula is, let's customize it to this problem. Tangent of what?
58.
58. Deep angle, good. Equals? Good. Opposite, 78 over x. And depending upon which version we've got, whether the x is on top, or the x is on the bottom, or the x is over here for the angle, you've got a different way of solving it. But all of them you're looking to solve for x. Usually it starts by doing what? Yep, cross multiplying. So put that over 1. If we cross multiply, we get x times tan 58 equals 78.
Can you divide by the
Yeah, we look at x and we say it's being multiplied by tan 58. I don't want that. I'm going to divide by tan 58 to get rid of it. If I do it to this side, I have to do it to this side.
48.
So x is exactly equal to 78 over tan 58, which is approximately equal to, I'm hearing 48 something or other. 48.74. That would be my answer. I know that this worksheet is asking me to round to the nearest tenth, so that 4 is not going to round to 7 up. Instead, it would be 48.7.
And it's feet, right?
And it's feet. Good. Yeah. 5. I could do that problem myself. If I had to figure out how far I was from a lighthouse, I could do that. 3. I would stumble a little bit initiating this myself. I followed your logic, but I didn't quite feel confident doing it myself yet. 1. I'd just measure it, wouldn't even try to calculate it because that wouldn't work for me. Good, you'll have a little more chance to practice this. I want to show you one depression, angle of depression, because those can be harder. All right. This is number 6. Actually, would you please sketch a picture for number 6 before I sketch mine? It's on page 2, a pilot in a helicopter.
What is it?
Pilot landing zone. This is geometry, not acceptance. Very good.
Yeah.
Good. It's a beautiful helicopter.
Wait, what? I was not crossing. She was, yeah. Looks like a pineapple. Or a tornado.
Almost. The picture's lovely. But your angle of depression is not quite right.
Oh, I did the same thing.
Oh, no.
Would that be the one of the other side? Yeah, because you started.
No, you started on the way off.
Okay, so there's no triangle here, right? For this unit, you gotta have triangles. So where's our right triangle? Well, it's asking us eventually, what's the altitude of the helicopter? So in my mind, I'm picturing, okay, so how tall is it from here to here? That's my x. And then it's saying, okay, but how far is the horizontal distance to the pad? And it tells us that's 1,200.
Oh.
But the pilot's looking down, and there's our triangle. How many of you drew a triangle like that? Okay. How many of you instead drew a triangle like that? Also fine. Either one works. This doesn't intuitively make sense to me to say that this is the altitude when it's not underneath the helicopter, but it totally works. This one makes more intuitive sense to me. Here's our right angle. But the angle of depression is harder to see here. Where does the angle of depression go?
It's not really there.
It's not here. Instead, you have to go from the horizon and depress your gaze. So if I went from the horizon and depressed my gaze, and what was it, 58 degrees? 73.
Oh, so you can subtract that from 90.
You can subtract that from 90 to find this one because it's a right angle. So you could say 90 minus 73 equals 17. Or, Peter, what did you notice about this angle versus?
Oh, those two angles are the depressive angle and that other interior angle are the same.
Turns out the angle of elevation and the angle of depression will actually be the same. So you could have written it down here. That's not really the angle of depression, that's the angle of elevation. But if that makes more sense to you to recognize that it's down here and those two are the same, that would be fine. Now, let's get kind of crazy here. So do you agree that we could mark that as 17? How big is this angle?
73.
Aren't they complementary? Because in a right triangle, the two non. Yeah, so it's going to be 73. I would like this side of the room, here on the left, all of you guys, I want you to solve the problem using this.
73.
Using this angle, this is your eyeball. You guys over here, I want you all to solve it with the 17 up here that you fixed by subtracting from 90. Your eyeball's up here.
Oh.
Way too many X's in that picture. rudder's got 2 of them, the landing spot, and the airs. I trust you to figure that out.
Wait, so no matter what, the angle of depression and the angle of
Elevation.
are the same no matter what?
I mean, I guess there could be a scenario where it's more complicated than that, but that's
Is it a
different.
coincidence that a lot of these are TOA, or is that like
It's not a coincidence per se. You know when you're driving down a steep road and it says, you know, adjust your brakes down because it's about to be a steep slope. When they talk about slope of a street, that's like rise over run, which is the tangent. It's most useful. In order to get cosine or sine, you're talking about the hypotenuse, which is that slanted side, which doesn't play into real life as often.
Whoa. I don't know if I did that.
Yeah,
Is my number too big?
let me see. It should be pretty big.
Oh, okay.
It's a helicopter
Wait,
flying.
if tan stands for tangent, then what is cosine?
Cosine and sine.
And if I drew this more to scale, 73 is a really steep angle, isn't it? So 1200 down here means this part's going to be really high. So if this is 73 degrees, that's most of the way up to 90. What you got?
So
Yes.
You guys get that too? So again, it doesn't matter which angle you choose, because if you choose a different eyeball spot, it'll flip your opposite adjacent.
Yeah.
So you can go either way. Okay, feeling good? All right, that's all I've got for you today. Give you the rest of the period to work on this packet. It should be due tomorrow. If you have any questions, ask me. Yeah.